Can you hear me? Now you can hear me. Okay. Did you have the coffee? Why didn't you grab your coffee? Come on, people. I mean, this IT conference, we are supposed to learn, right? So without coffee, this might be challenging, right? We are not coding today, but we are like learning ton of interesting stuff. So coffee might be helpful, right? Welcome to the session, Sailing Modern Java. And because there was a very nice keynote, and we also had like other sessions talking about like features, like what are the new features of Java and so on. I decided like this was like yesterday's evening idea to like be a bit more creative or like tune the presentation a bit. So today we're going to sail the less charted waters, so to say. Therefore, I'm not going to like reintroduce you to Loom and everything like with every boring detail. Instead, we will try to run some demos, right? And with demos, the thing is with demos that sometimes the demo gods aren't with us, right? So things may blow up and everything. So it's better to play it safely. So let's prepare like some environment in case something doesn't work, right? At least I will be wearing some safety suit and maybe some safety glasses. All right, very nice. So my name is Piotr Przybyl. You can find me on Twitter, if you will. I am working as a software gardener. If you don't know who knows what software gardener? Like, what's this role? Okay, I don't see a hand, which means you people have to read a fantastic book called Pragmatic Programmer. Sometimes I also work as a trainer. My daily job is at Atomic Jar, right? So we do things for test containers and around test containers, right? And I every now and then blog post something on softwaregarden.dev, which is my personal blog page, all right? So most of my professional life is Java or JVM and things around. So even when I go on holiday, provided there's a holiday, of course, Java is somewhere behind me. And now the question is, who are you? Who's a Java developer? Nice. Who's Kotlin developer? Still a lot of hands. Scala developer? Okay, I just see 2, 3 maybe. Okay, who's stuck with Java 8? All right, Java 11? Java 17 and beyond? Who likes voting with left hand? Who likes voting with right hand? Very nice. Now we know each other. Hello. Welcome to the session. Little warning, caveat auditoris. We are going to sail the uncharted waters. So again, like I can make mistakes. Like nobody's perfect. People make mistakes. I make mistakes. Don't trust talking heads on the internet, right? Especially these days. Errae humanum est, right? So. Quick reminder, there's the Slido thingy, right? You join GeeCON 2022 and there should be like room 6, right? Ask questions, should we have time? I'll try to answer some of your questions, at least, maybe all, we'll see. Yes, and I might try to answer the questions if you have like after a particular chapter or something, we can try to answer the questions sooner, right? Not at the very end. So please ask questions during the presentation, don't wait. So, these are the JEPs of Java 18. They are like plus minus 1. There are 9 of them, right? So we can see there are a lot of like lovely stuff that comes to Java, right? Every 6 months. So this was like half a year ago, more or less, or 7 months ago, right? This is what happened to Java more or less officially. I mean, with the GA like a month and a bit ago. So these are like 7 JEPs, right? So now you've seen this all. Thank you very much. Enjoy the next coffee break. It's not the case, right? That's not. The question is, and you're asking yourself this question, right? And your managers ask you these questions, your team leads, your tech leads, and of course the dragons that keep the budgets under control, right? Shall we migrate to the latest Java, being 19 in this very case, or shall we stick to the latest LTS, right? Or even something before? And the answer is, it depends. Of course, it depends, right? So if your software runs on a latest Java, actually I think you should upgrade it, because you should flip the question, right? You shouldn't ask why you shall migrate. You should ask why I shouldn't migrate, right? That's the thing. That's the mindset. Just switch your mindset, people. And maybe we should skip having or testing production in our production, like the so-called preview features or incubator modules, unless we have like a very prosperous business around these features, right? Like Helidon Nima, for example, like we saw yesterday. Or like one important thing is that non-LTS release of Java doesn't mean that it's banana soft or monkey soft or anything like this. So I'm going to show you like the only wall of text during this presentation. Please don't read the wall of text, but bear with me with this whole snippet from Mr. Mark Reinhold's mail. And what he says here is whether the target release is an LTS or not is, in almost always, completely irrelevant. Meaning the LTS is business term, more or less, than a technical term, right? That's it. I mean, for the we need to have like license for a bit longer because support or something like. We should be running on the latest version Java, and that's it. Period. Case closed. So there might have been a change, or maybe there is a change. I mean, for me, it's a bit unclear. Again, like I can make mistakes, but it seems that we're going to see LTSs not every 6 releases as initially planned, but every 4 releases, right? So if you think that upgrading your JVM every 3 years is a bad idea, now you'll be softly pushed towards this every 2 years, right? And I personally like it very, very much, right? So what are these preview features? Has anyone ever used the preview feature of Java? Why so few people? Come on. Well, I mean, what's the other or better way to waste your Saturday evening? Come on. Like, getting intoxicated with some people? Come on. There's a tech stuff to be tried out. Really? That's a better thing, right? Okay. So, implementation of JAP 12, right? So, it's like, to boil things down, it's about adding to a compiler and to your runtime and your Maven, Gradle, and IDE -- enable -- preview thingy, and that's it, right? Okay, there's like a target and everything. I have details for you in this presentation because I had more time at that time. Now we don't. So these are like many of these are preview features, so you have to opt in for them, and you can't cherry pick. It's either you use them all or you don't use any of them. So one of the changes, and I'm like kind of surprised it's not particularly popular in our part of Europe, so to say, and it's using UTF-8 by default, which is a standard feature of Java 18 as JEP 400. So I like the number, like 400, right? You know, like this, like something bad in the request and stuff like this, right? So what it's all about is just from now on, things from Java I/O will use UTF-8 by default unless it's specified explicitly. Meaning, I mean, this shouldn't be a problem for Linuxes because they're using like UTF for quite some time like already. This shouldn't be a problem for Macs. There might be a problem for Windows, right? Because Windows was using this. I mean, it depends like what you locally or whatever. Might use something else. So what's important is now if you're calling this since Java 18 onwards, character or car set for name default, it will throw an exception, right? And you can use this flag. They say that it's compatible to have it still compatible with your platform or switch to UTF-8. Like, it might not be clear what does it do, so let's do some demo with in the code, right? And I'm going to use, I mean, we're in Prague, so I have to use IntelliJ, I guess, and pay attention to this nice splash screen. Yes, very nice, very nice. I have to use Java 18, I guess. Let me open it. Very nice, new window. If it's too small, shout, yell, don't throw hard things, please. Right, because people have wild ideas. Right, so I should have something like this to give you an idea what it means and why it might be important if we are about to migrate stuff, right? So the thing is, this is the thing, right? We have this input stream reader, and on Linux or Ubuntu, it works pretty smooth, I would say, or pretty much as I would expect it. Righty, run for me, please. Yes. So you have this lovely sentence. I mean, I'm reading 2 files. One it's encoded in UTF-8, and one it's encoded in Windows 1250, right? And it's in Polish. So it says, pchnąć w tę łódź jeża lub 8 skrzyń fig. And it doesn't make much sense, but it uses all of Polish characters, right? So if you have this Windows 12.15 encoding, right, it looks like rubbish, but it still has 51 characters. And this is how it works on Linuxes. And how it would work on Windows, and I'm not going to demo that today because, I mean, I don't want to interfere too much with demo goats, like demoing Java is enough, why should I include Windows? Okay, all right, forget this. So let's demonstrate how this would work or how it works on previous Java versions on Windows if you don't specify your character set, right? So it works like what's the name? 1250, it should be this thing, righty. So if you didn't specify anything on Windows, it looked or implicitly worked like this, right? With using this, I mean, in Poland, of course. In other countries, that's a different thing, right? But it's up to you to check it. No pun. Yes. And then, as you can see, this is how it used to work on Windows, right? If you had Windows encoded files. And now, if you don't have this specified, this thingy, right? Or you don't change the file encoding and everything, it will work like this, because now this will be a new default, UTF-8, to provide the same experience across all the platforms or operating systems, right? So, see, instead of having 51 characters, you will have 60 of them, and there will be some kind of rubbish, I would say. So pay attention for this when you're migrating your applications. I would say mostly desktop applications which are using text files, and you don't have the character set specified, right? So this might be a bit tricky. Writing. Next thing, deprecate finalization for removal. Who's using finalizers? Yaroslav, why are you doing this to me? Yes, new standard feature of Java 18, right? This JEP. And now the thing is, the beautiful thing is finalize is deprecated for removal. You're not using finalizers and finalize method, and it's very, I mean, like a lot of you as an audience, right? And the thing is, now it's deprecated for removal, and we will have this compiler warning and Java flight recorder event if you happen to use finalizers or this finalize method, right? And we can simulate future. You know what happened to the serialization, sorry, not reflection and everything with JEP 403 in Java 17 and 16, right? So they disable and eventually remove the thing. So the same may happen with finalization, right? So, so future versions may need finalization enabled, and we can already simulate how our system would work when the finalization is gone or when it's not used. And now let me show you why this finalization thingy might not be, so to put it nicely, a thing you want to do. So this is a code which you shouldn't be doing at home or at production, right? What does it do? It just allocates an insane amount of like objects or arrays in this very case, right? And to make it work, I just limit the memory to 100 megabytes, right? And what we also have, we have this finalize, which is now, as you can see, which has this red thingy, like this snail or whatever, saying that it's now deprecated for removal and everything. And what it does, it just says, I call finalize on this thingy and the name of the thread. Question, what will happen? Ideas, what will happen? Come on, people, don't be shy. No, garbage collector won't be ignored in this very case. Any ideas what will happen? It won't compile? Oh, it will. Any more ideas? Quickly, we're running out of time. Don't be shy. It will run, but what will it do? Yes, it will blow, exactly. I have jellies for you. Will you catch them? Come on, I try. I throw, you catch, okay? Perfect jelly handling, okay? Okay. Yeah, he got it. Very nice. Very nice. Let's run the thing. Let's run the thing. And let's see what happens. Oopsies, daisies, out of memory error. Who could have known? Yes. Why? Because we're allocating the objects and putting them to heap like crazy, and because of this printing in a finalize method, which is naturally slower, the garbage collector can't keep up, right? And we're just overusing this simple finalizer thread, right? So this is bad code. You don't do that code already, right? But we can simulate what would happen in the future, and we can like go and, so beside that, it's like red now and marked as deprecated for removal. We can simulate what will happen in the future, and in the future, something like this should happen. Let's go here, modify run configuration, and let's add a parameter and hit OK, and let's rerun it. And what does it do? It runs, right? And it removes the objects from the heap. It's just now it skips the finalize method. And that's the thing. You shouldn't rely on this, right? It's unreliable. Finalize method is like, it was always more like causing more problems than solving pains. That's the thing, right? So finally, let's forget about the finalize method, and you can like finally pimp your system, right? Throw this flag, finalization disabled, and you can enjoy, right? Not worrying about the finalized thing. And if you see something like this, or just the finalized method being override, is generally a red flag these days since Java 18. Very nice. Next thing. Yes. Simple web server. So there's another standard feature in Java 18. And what does it do? So it exists only for testing and development purposes, right? You don't go to production with this thing, right? Really, you don't. It doesn't support HTTPS or any other sophisticated features. It can be called from your CLI, like you just go and web server and toss some options, or you can do it from API by create file server, and then you can do or whatever you please or whatever it's supported, right? So I will show you maybe the code way, right? So we have this server, and like again, demo only, don't do it like in production. But what are we going to do? We're going to create a simple file server on port 9000, and we're gonna host things which are in the server directory here. So as you can see, I have like 5 files here, right? And what I'm going to do is like whenever someone is going to hit style, for example, I'm going to overwrite it or like replace in totally insanely like irresponsible way, but this is gonna happen, right? I'm gonna replace Indian red with dark blue, right? So let's hit run button and let's see what happens. Righty, very nice, come on, come on. Okay, maybe I should switch the profile to go for like the beefy one. Sorry, like even the performance one. So it should be, does it run or doesn't it run? Not run, let me see. It seems to be running, but nothing is in the console. Let's see if it runs or not. Local host, maybe the demo gods aren't with us. Oh, it does, right? See, so it's like I can quick now, so I have this index, right? And I can like things, click various things like different pages, this C, B, A. And as you can see, normally they were Indian red, but on the flight, they kind of like, this is the color, right? I replaced it with dark blue, so we can do this. And you can also run this thing, as you can see, there's like an access log, right? And you can also do the thing, there should be README files. So from this, you can see we can go somewhere like to this directory and run it directly in there. So, okay, let's just for a sake experiment, it's so fun, right? Let's go here. Let's run it. Let's click it here. Yeah, so this is how, how it looks, you see, when I'm just running it from the CLI, right? Very nice thing. Very nice small web server. If you just need to host some files, I don't know, you need a quick server to experiment, basically. So now you don't have to deal with fancy stuff. You can, I mean, Java 18 and onwards has this thing for you. Right, code snippets in Java API documentation. Who's using Swagger? Okay. So Swagger. So we're not going to have like interactive documentation, right? Where you can point and click and something will happen, or it's not like this JFiddle or JSFiddle or whatever, but we're gonna have snippets which are much nicer than this pre thingy, right? And in Java, so it's new tag for Javadoc, it's about this modern styling, it's easy to validate and support in IDEs, it's not interactive, please keep that in mind, and it can support internal and external snippets, and supports not only Java syntax for that matter, or righty. So how does this work? Is it Java 18 or 19? Because I forgot. No, it's 18. Very nice. So I have these snippet files and I have this sample demo, and this is a demo like how people can use this sample Javadoc thingy, right? And I should have this how's it called? Javadoc sample, right? We have it, right? And it's quite like, let me go to this edit mode so you can see. See? And this is how it looks like. So this is a Javadoc, and now I have this snippet here. It's here, right? It's the snippet. And now, as you can see, the IDE is like interpreting this as a Java code, basically. And I can, like, basically, so this is like to generate nice Javadoc, right? And then we can also say, so this is so-called internal snippet, right? And it can also be an external snippet. So I can say, please include this file, like the whole file, and even like have this, from this external file, just include a region for me, right? And this is it. And then when we go and, let me go to terminal back again, make it bigger. Let's go back and again, README file. You people read README files, right? Who reads README files? It's always about this funny Spanish guy called Manuel. Really. Okay, so what are we going to do? Do I have this? Don't I have this? I do have, yes. So we can generate this Javadoc like this, for example. We put it that the demos are here, right? And then we can, again, see, now we can use the JWeb server, right? Because it's like a new way to host things. And does it work? Yes, let's see if it works. And now I have to reload, of course. Yes, and this is it, right? So this is Java, new Java doc, and see how it looks like in production, so to say. So I can copy these things, right? Like the host, like the just internal things, or the whole file, like this is how we should use it, or the like just this region. And as you can see, I can make things bold, and I can make part of this even clickable, right? So I can click on this string, and it just takes me somewhere, righty? And how does this work? Let's go to this region again, and as you can see, I can instrument with like highlight this regular expression, or make sure that this substring is a link to this thing, right? So now we can pimp our Java docs, because remember, we should read Java docs and we should write Java docs, right? Or in like any kind of documentation for that record, not only for us, but also for future generations, because the situation when you say, oh, yes, we do have documentation, only it's passed in oral tradition, isn't quite fortunate, right? Okay, foreign functions and memory API. Do we have some JNI users here? Okay, all right. Righty. So preview feature, it's like another preview feature after merging some JEBs, going from, I don't know, like incubator module into a preview feature. Basically, the story around this starts to resemble Bold and Beautiful, like if you like the soap operas. Anyway, I think it's getting us closer. And I would even say it's very nice that it takes so much time, because last thing we want is another optional .get, really. So it's really nice that they pay attention and have some feedback and everything, righty. So what is it about? There are two things. First is how to access the foreign or native memory. Not only native, but it can be native, right? So we should avoid limitations of byte buffer, which is 2 gigabytes, for example, right? It should be safe, unlike SunMISC unsafe. I mean, even the name said unsafe, right? Unsafe. And some people said, yeah, we'll be safe, right? Read the freaking manual. Okay, it should perform equally well than JNI, maybe even better, right? And what are the building blocks? So it's the memory segment. It can be a native thing. You can like say this array is my memory segment, things like this, right? There's memory address, because you can get it like internally, or maybe like an external tool or program, right? Can pass you the memory address. And there's memory layout. So you can say, for example, in this segment, starting from this address, I'm going to keep Java longs, for example, right? So I need to know what's the layout of the things that are inside. And the memory session is about having the boundary of time and thread, because as you can see, the memory segment gives us the like spatial boundary, so to say. So it's like from here to here. Remember, the memory in the computer is linear. It's not like two-dimensional, it's linear, right? And then we have also like other boundaries which are about time and thread. And this is very nice to try with resources. And we can also use var handles should you like to use them. Right, so quickly, how does this work, or how can it work if you need to call like some native stuff? This is it, I believe, right? So as you can see, we have this. Let me see if it runs in the first place, right? Maybe it doesn't run and I'm just bothering you and it's like, no, it does. Oh, come. How come? Very nice, it works. Okay, so in same thread demo, how it works is quite simple, right? We say memory layout, and I just want to have sequence layout. I mean, this is not the only way to use it. This is just an example how you can use it, right? So let's say in memory layout outside of the heap, we want to keep 10 Java ints, right? So we tell a memory segment to allocate this thingy, and we have just memory session open implicit, meaning we don't care about time and thread boundaries, right? And we're going to populate this memory, and we're going to then see what's inside, right? So when we populate this memory, basically I can go something like this. For example, I can go over this loop, right? And then I can say at this index, set a thing that is a Java int, right? And just for purposes of demo, I'm setting the same thing as the index. See what happens if I just say, if I do this off by one error mistake, right? And I introduce equals here. What should happen? Okay, it went belly up, of course, right? But as you can see, index out of bounds exception. So we are not like accessing the memory that wasn't pre-allocated for us, right? In this term, it is safe, unlike SunMISC unsafe, right? So see, this is like the spatial boundary, right? How do we read? We can read in many ways, but I can go, for example, like from this segment, get me whatever it is at that index. So as you can see, I don't have to like compile anything. I don't have to do like these crazy stubs like .h files, .c files, and any other kind of crazy files. I can access the thing right from my Java code, and I can even have this. I can define my own layouts. For example, I can be keeping there like for example, I want to have an array of structures. You know, in C, for example, we have these structures, and each structure is an integer, and a long, because why not, right? And then we can tell Java that this is my layout, and Java will keep me secure that I'm actually accessing the thing, not something else. Righty. So let's just quickly demo how things might work if we try to run 2 threads. Oh, whoa, whoa. And yes, already closed. Why is it already closed? Very nice, because I run things too fast, right? So instead of relying on this try with resources block/idiom, right? I decided to close the session earlier, and therefore I cannot re-examine the session, this memory again, right? So as you can see, it makes sure that the memory doesn't leak after I decide to close it, right? So it's not accessible anymore. I just get the exception, and that's it. I have to deal with this. So let's try to rerun it again. And now, yes, it works very nice. And we can see that now, because I opened the memory session, which is confined, it's owned by a thread, right? It belongs to someone. It's not just null thingy. It belongs to someone, this given thread, right? And then I just allocate it and everything. And then let's say I want to read it in another thread. You see, I'm creating a thread, which is not virtual for the record, right? But yeah, just a thread. And as you can see, now we have a different exception, right? Wrong thread exception, attempted access outside owning thread. So this thread owns this memory segment. So why are you, the other thread, trying to access it? No, you can't do this, right? And therefore, we ensure, you see, that who can write and read to this region when this can happen, right? I mean, after it's closed and released, it cannot happen. And like, what's the layout, and where does it begin, and where does it end? So very nice way to handle native memory, if you need that. And there's also another thing coming if this MFFA is called. It stands for foreign. I don't know. Okay, there's a foreign linker, right? So that was the memory, but now we have to call native stuff, right? Right, so again, replace GNI with pure Java development model, right? No messing with some fancy files. And for now, it supports C on these architectures. In the future, it might support other architectures and other languages, right? And the performance, again, shouldn't be worse than GNI, hopefully better, right? And this is like the project Panama, if I'm not mistaken. What the linker allows, it allows 2 things. Oops, it's the wrong button, sorry. It allows so-called down calls. So I'm calling I have a function written in C, and I want to call it from Java, right? And I can also have up calls. So I have this very nice method in Java, and I want to call my C code, and then I want the C code to call my Java code, because, for example, it's a nice comparator, and I need to I have this super efficient sorting algorithm in C. It's just I have a comparator in Java, so I want to go here and then there, back to Java. So it's called up call. That's the thing. And yes, so let me demo how it can work. Yes, so we have this foreign linker API demo. So what the program does, it does this thing, gets the UID, right? And this is the native thing. So I have the native linker, right? I'm just using standard library, and I'm just looking for a symbol or function called getUID, right? And in case I cannot find it, it's like I'm expecting an exception. Let's say it's going to fit a Java short, right? And then I'm going to make this down call handle. See, it's all Java code, maybe except this string, right? So this is something I have to match, and then I need to know what's going to be the result. So I need to describe it pretty much like I described the memory layout just for the previous example, right? And then I'm invoking the thing, right? And then I'm checking if the thing is root, because maybe I don't want to run my stuff as root, right? Because, there will be dragons. So if the thing is root, I'm going to say, no, you don't run me as root, please, because I might be dangerous to you, to your stuff and everything. The question is Because this thing is so old, I mean, so old, I named for like 4 Java releases or something, right? I was demoing that always on my Linux, and it was like, okay, but we can't have it because I have like Windows and stuff like this. So I came with like a better idea, I hope, which is more clever. So we're gonna use, surprise, surprise, test containers, right? So what we're gonna do? We're gonna start a generic Docker container. We're gonna copy the jar file, right, which we generate as this thing. And then what we're gonna do is what we're gonna call Java with enable preview in this jar and the thing, and we're gonna check if the exit code is non-zero, right? And if it contains this, oh no, don't run me as root, please, right? So let's see if this thing works. Come on. Come on. And oops, it's pulling the image. Oh, righty. Okay. The Wi-Fi might not be the fastest here. Oh, no. Okay, I know what's happening. I'm demoing something else by accident, which is actually very nice. Okay, yes, now it's done. Yes. So we are now sure we created like a proper integration test. As you can see, we are testing this jar if it behaves as it should be behaving. So when I'm running this thing as a root, right, then my program just exits with non-zero code and says, oh no, don't run me as a root. And the thing I demonstrated to you accidentally was actually test containers cloud. I mean, the thing we're working on, but sorry, like I forgot to turn it off. Very nice, but it also like it should work on your machine, right? So now having Windows is not an excuse for running these demos. Very nice. So another thing, virtual threads. Who's excited about virtual threads? Many people, but not all hands. Okay, who thinks that thanks to virtual threads our applications will be faster? It depends what the application does. If it does a lot of blocking I/O, it might get faster. Most probably it will get faster. But if it's about like raw CPU computing, it won't be faster, right? Or not that much faster. So again, preview feature of this JEP, very nice. So it's about keeping concurrent threads model as it is now, right? And allow this using this idiom/paradigm thread per request nicely, so it's so we don't have to bump our heads again against this reactive wall, right? And then it's nice for debugging, troubleshooting. It's to improve the scalability of asynchronous code, and it's to be in this good all imperative style and stack traces, right? So quick demo. Let's keep the demo spirit. Where do I have it? I should have it. Yes. What are the differences? There were like excellent questions yesterday at one of the sessions, and I just happened to have the answer for many of them. So as you can see, we can these virtual threads can only be daemons. They can have only normal priority. You can't make them like have high priority, for example. They support the local variables by default, right? But we can opt out from the thing and so on and so on. So you can run this test as well. Let's see if it does run. Yes, it does, right? And yeah, so that's pretty much it, right? It even supports inheritable thread locals. So in this regard, it should be transferred to application if you're using virtual threads or not, right? So this is like, I encourage you to start playing even with Java, right? Like this way, because testing is not only about testing the stuff. It's also about testing your assumptions about the stuff you're about to use, right? So now we have the assumptions written here, right? As a test, it's a code, it's not a documentation then, therefore, right? At least not formally, so we can rely on this, right? Back to the slides. So, virtual threads won't magically squeeze more juice from your silicon, right? Your CPU won't be faster because you're using virtual threads. It's not gonna give you like gigahertz or megahertz or anything like this. If that was your hope, abandon it, right? It will unmount the carrier platform thread when it's parked for blocking I/O, right? And then the carrier or the platform thread can be mounted by another virtual thread. Think like car sharing or taxis, right? The taxi doesn't have to wait at the restaurant's door when you're having a lovely dinner with your family, right? They can give a ride to other people, and that's the thing, right? But there's still the limited number of taxis and streets and everything. So magically, you won't be able to, I don't know, transport millions of people, right? It's just you will require or will be able to transfer more people within the same set of hardware, so to say, right? Unless they are pinned. Who knows what it means when the thread is pinned? This is a thing that we shouldn't be doing. So, who's using synchronized things? Okay, and the thing is, synchronized comes with great responsibility. And if inside synchronized block or a method, we are calling a blocking operation, and these days there are two instances of such blocking operation, which is either I/O or calling native stuff, the thread will get pinned, meaning the platform thread won't be able to be like taken and given another virtual thread to run, right? As this continuation or like in Kotlin WB coroutine and everything like this. It will have to stay there and keep the engine running. And we don't want to do this because this will, have a negative impact on our performance of the system we're doing. So, trace pinned threads, you can set it as to full or short, or you can listen to JFR events. And let me demonstrate to you how we can do this, right? One of the trickier things, one of the trickier demos I'm going to show you today. But let's see. Maybe the demo gods are still with us. Right, so what I'm going to do here, right, is basically what shall I use? Like, the scenario is like this. I have a simple HTTP client in Java. And quite unfortunately, I'm calling it from the synchronized block. And then what's the best way to simulate your network setup with latencies, jitter, and stuff like this? Of course, test containers. Why not, right? So we are wiring two things, Nginx container and Toxic proxy, and we put them on the same network, right? And then we start them in parallel. So I'm simulating that I have a web server and the network, which is like, who believes that network latency is always 0 and networks always works? Again, see, no hands. And who simulates that in their tests? Yeah, that's the point. That's the point, right? So I'm simulating the non-zero latency of my network here in this very test, right? And what I'm going to do, you see, I'm going to have this client, and I'm going to call this this proxy thing, right? And I'm going to start only 20 threads, right? And these are going to be virtual threads, and just for sake of monitoring, we're going to see if they were created or not, right? And this is like a dummy way of intercepting the standard output, because what this thing does, I mean, this parameter of trace pin threads, it just prints to standard output that the thread got pinned, and that's something you don't want to do, right? So first, of course, we need to fix this test, right? So we never go for disabled tests. We fix the tests, right, instantly. And now what shall we do? What shall we do? We're running this thing. We capture the output, and then we assert that the test stream didn't have on pinned, right? This is what we want to achieve, right? So let's run the thing as debug. Sorry, as run. Oh, and this test failed. Why it failed? Because I didn't set this parameter, if I'm not mistaken. So I'm asserting that the trace pin threads is set. So let me set it, right? This is the flag. Righty, here, and modify run configuration. Yes. So now I want the JVM to print me whenever I'm pinning my virtual thread. Let's try to run it again. Okay, now the preconditions are met. Very nice. Very nice. Okay, network connectivity seems to get better. Very nice. Yes, one of the containers started, and the thing failed. Why did the thing fail? Because the assertion failed. This very assertion failed. Because what did it do? You see, It's just, instead of having just the like created thread and that the given attempt to call this thing finished, I also have this stack trace. So maybe instead of like this running it now as a test, let's just print it to standard output and let's see how it feels like, or how it would feel in production instead of having this as a test, right? Okay, let's run it. Yes, very nice. And this is what you see. This is what happens after you use this flag with show pinned threads and you have pinned things, right? As you can see, this is it. So it will output you that you have like on pinned thread, and this is exactly here in this get greeting, we are pinning our thread. So in case you have to have a synchronized thing, you should go for like reentrant logs and everything. Here, it's like having synchronized here would just pure nonsense, so I'm going to remove this thing, right? And let's see again if the tests, if we see the warning or not, with our flaky network, of course. And now there was no warning, so it seems that we didn't pin a single virtual thread, right? So now I can like reestablish the test again. So I'm printing to this accumulative stream, right? And let's see if the test passes or not. Does it pass? Please pass. Please be green. Yes, it passed. It means now my JVM didn't detect a single virtual thread being pinned, meaning I'm not waiting on blocking operation inside synchronized blocks if they are run by virtual threads. Very nice. This is what we should have. And I guess the last thing I'm going to show you today is the structured concurrency, right? And I hope that Grzegorz won't be disappointed with this, but like maybe futures don't have that bright future anymore. And maybe that's nice. Incubator module in Java 19, so structured concurrency. It's about having better idioms for multi-threaded code, right, to help eliminate thread leaks and cancellation delays without touching current concurrency stuff. So if you have like a code around concurrency stuff, it shouldn't change, right? And it's forcing libs for certain to use certain constructs, for example. And it's not about replacing interruption with cancellation just now, but it might change in the future, right? Yes, and we have these two structured concurrency kind of like policies, right, or scopes. And let me show you just again a demo to better illustrate what I mean with this. We should have structured concurrency thingy here, right? So we have name service and score service, and we're building another service that's supposed to like kind of like we're simulating microservices, right? Grab data from one service, grab data from another service, then combine and return a scoreboard. That's the whole business logic in this demo, right? So how do we do this initially? We go for the sequential thing, right? So we call names from one service, we call scores from another service, and then we combine them and return them, right? And so let's run the thing. I'm not using the incubator module, see, so like this enable preview, we have to go here and modify the rank configuration, and I'm using it, okay. Oh, sorry, I was using it, yeah. It was just the warning that I'm using it. And as you can see, the call to, okay, it's not a proper benchmark, okay? It's not scientific approach, we're just experimenting, okay? So take it easy. Right, so it took 2 seconds. Right? Because we discovered that this takes more or less 1 second and this more or less takes 1 second. So if you have 2 independent things and each takes 1 second, what do you do? Come on. Yeah, who shouted parallel? I've heard like I've heard 2 people. It was you, okay? You don't want it? Okay. Someone else said like go parallel. Who was that? Someone here. It was you. Okay, I throw you a catch. Okay, you'll have 2. Sorry. Sorry. Pass it. Okay, thank you. Very nice. Yes, we go parallel. We go parallel. Of course, we go parallel. So what we do, we go like this future scoreboard, right? And this is it. And we run the thing, right? And we run it like for our things. And very nice. Success. 1 second, right? It's just, then there's this thing. Sometimes, you know, it's network, right? It's the services. It's the real world. things might not work. So what happens, for example, we go here for this get names, right? And sometimes it just happens, for example, that the things goes like after 1 second it crashes. So now, question, how long the execution of this will take? 1 second. Who said 1 second? It's you again. But it's not too. Let's see. Let's see. Let's evaluate. I mean, if you want more, go and grab more, right? Yes, it's more or less 1 second because it takes us 1 second to discover that the thing doesn't work, right? Very nice. I mean, it's not nice, but at least like our predictions were correct. And now let's assume that this thing doesn't break after 1 second, but it breaks instantly. Question, how long the execution of this will take? 1 second, you say. Yes, very nice. Let's see. Yes, and what we should do to make it be much shorter, like close to 0 seconds? Yeah, exactly. And then we open Hell's Gate, right? And we have to react to these cancellations and propagate and everything, right? So what we can do instead, since Java 19, we can go for the structured concurrency, right? And we can go for something like this. Which may look quite similar, but it's now we have the structured scope, and whatever one thing fails, we just want to shut down, right? And we want to grab the names and the scores, and we wait for them until they arrive. If something breaks up, we will just want to throw an exception, right? And then we combine the results. And now let me run it again and see. Now we know instantly, because when this thing fails, in this structured task scope, it informs all the other things or tasks, hey, there's like, we should shut down on failure. There was a failure, everybody shut down, right? There is no point in waiting for the responses and everything like this, because it doesn't make much sense, right? And it also keeps it secure for us, because if we forget to join, like accidentally, it doesn't work because it says task has not completed, right? It throws such an exception. Yes, so that's it. Now, please allow me to skip pattern matching. A lot of, interesting stuff happened. So, for example, we're gonna have in Java 19, 37 new emojis in case you really need them. You know, you might need them. What might be important since Java 18 that there is string deduplication for other garbage collectors, right? So if you have tons of strings, this might be interesting for you, right? And there's like other stuff, 2 new properties, standard output and standard error encoding, system properties, right? Some stuff got deprecated, like thread stop got terminal deprecated, and locale constructions, now we should use locale.off, right? Some stuff got removed, which is the implementation of the plain socket and plain datagram socket, right? And now, we're going to go to questions, but before we go to the questions, please always provide feedback for the conference organizers. You're doing this for yourself, because based on this feedback, on these ratings in Slido and everything, and your comments, they will be able to tune the next edition for you and for your needs, right? I can accept feedback in any form. It can even be a written paper. I mean, since this is like a proper, like a real meeting again, yes. And if you're watching this on YouTube, because not everyone is privileged to join us in this room, please then go and fill this poll, or if you like prefer to fill this anonymous for questions poll, I will be also happy to do this. So even if you're watching this like a few weeks after or months after, please go and hit the subscribe button, right? Of course, that's the thing on YouTube, right? These are the slides, the code for you, everything. Děkuji mnohokrát. This is me on Twitter. If you're about like some IT insights, changes in Java and pool life advices, please follow me on Twitter. And this is the slides for you. I mean, if you like to get access to everything that just happened. And I believe we might have a minute or two to answer a question or two. Okay, so some people taking a picture. Okay, I guess that's everyone. Righty, so let's see, what questions do we have? Okay, Yaroslav. Okay, I was a bit of advertising, but nice. Do virtual threads have some non-blocking? Okay, it's like, come on, people. Do virtual threads have some non-blocking variant of thread sleep? Why would you need to sleep in a thread? I would say is an indication of a cold smell, right? You don't want to sleep. I mean, if you have to sleep in your thread, instead of using some kind of like I don't know, like locks, monitors, latches, semaphores, I think something went wrong somewhere, right? So I would rather say get rid of thread sleep. I mean, I was using it for demo purposes, right? But that was demo, not real code. Next question, please. How many coffees did you have before the presentation? 3. Next question, please. When I use snippet tag on any JDK, check code snippet for Javadoc project. It's is it like a friend of this? What was the name of the cake from the border? Fregal. Yes. Sorry. Yes, very nice. Like yeah, shameless plug from Yaroslav. Yeah. Okay. What was your sailboat on the first slide? I don't know that, but if you go to the slides, there's a link to the image. Right, it's not my boat, right? I'm not the CEO of anything, so I don't have the privilege of owning a yacht or a ship. Okay, thank you very much. I still have some Polish jellies left, so if you'd like to grab some, please enjoy. Thank you very much. Thank you for coming to this session. Thank you for learning. Dziękuję. Thank you.